All right, if we want to convert polar coordinates, which we looked at is always in the form of r theta, where r is the pole length and theta is the angle, to Cartesian coordinates that have an xy coordinate, we can set up and use some right triangles to do that. So if this is our polar coordinate here, r is our pole r here, and theta is that angle we'd measure from the polar axis, and we draw down the vertical and measure over the horizontal length, it would form a right triangle here. So let's use what we know about right triangles. If we want to find x, that's the adjacent side. Our hypotenuse would be r, and so adjacent hypotenuse, that's cosine. Cosine of our angle theta then would equal our adjacent side x over our hypotenuse r. By doing a little multiplying by r, this would then turn into that x equals r cosine theta. And so that's our conversion to find x. If we want to find y, we do something similar. That's our opposite side. And so doing something very similar here with opposite and hypotenuse, which is sine. Sine of our angle would equal y over r. And then again, doing some multiplying, we get that y would equal r sine theta. So that's our conversion to find y. If we want to go the other way and convert from Cartesian coordinates to polar coordinates, we're going to use that same right triangle, but do it a little different here. So if we want to find r, we're going to use Pythagorean theorem. If we got a squared plus b squared equals c squared all in here, then what that would turn into is x squared plus y squared equals r squared. So we're going to use Pythagorean to figure out our r, and to figure out our angle theta, we're going to use tangent, because tangent's the opposite side over the adjacent side. If we set up tangent, now we can find that angle based on x and y. So that uses a little trigonometry there to find that out. All right, so let's see if we can do some of these conversions. Look at some examples here. They want us to convert this polar coordinate to Cartesian coordinates. So first thing we're going to do when we convert there is use that x equals r cosine theta. So we're going to plug in what we know those are. So our x is going to be 2, because 2 is our r here. And our angle is theta, so we're going to put 2 cosine pi over 3. All right, now this would be something like on the AP test they might expect you to be able to do without a calculator. So you have to know what is cosine pi over 3. Pi over 3, recall, if you're not sure what that angle is, you could convert to degrees here by doing our pi over 180. So that's going to be 60 degrees. So if you had a 60-degree right triangle on the unit circle, that's 1. That means this length would be 1/2, and this length over here would be times square root of 3, so it'd be square root of 3 over 2. And so doing that, we see that cosine, remember cosine's adjacent side, cosine, that's our x, would be 1/2 over 1, or just 1/2. So this would equal 2 times 1/2, or just 1. So x would be 1. All right, if we want to find the y coordinate, y is equal to r sine theta. So same r and theta value. What is sine of pi over 3? Sine is the opposite side over the hypotenuse, so that would be square root 3 over 2. So y would be 2 times square root 3 over 2, or looks like y would just be square root 3. And so our coordinate then on this one would be our Cartesian coordinate would be 1 square root 3. So that would be the exact value of that one. All right, let's go the other way. What if you were asked to convert our Cartesian coordinate of 1, -1 in terms of its polar coordinates? All right, so here we're going to use our other way of doing it. So if we want to find what is our r, we're going to use the fact that we got Pythagorean theorem here of x squared plus y squared equals r squared. So if we plug in our x and y value, that's our x value, that's our y value, we get 1 squared plus -1 squared equals r squared. 1 squared is 1, -1 squared is also 1, 1 plus 1 would be 2. And so if we took the square root of that, that would tell us that r is, it would be plus or minus the square root of 2. Now, since we're going to be figuring out this angle, we really just want to use that positive value there of square root of 2. All right, to find our angle, what that angle is, we're going to use that tangent of the angle would be equal to the y value, the opposite side over the adjacent side, the x value. So filling that in, we'd get that tangent theta would be equal to -1 over 1, which that's just tangent theta equal to -1. If we're going to solve that, we could do inverse tangent here to see what we get. So what's the inverse tangent of -1? Now, if you got a calculator, you could definitely do that in your calculator. If this was not calculator, another way you could do it would be to graph that out and see what angle that would lie in. So 1, 1 would be this point. So if we wanted to end up at that point, we know it looks like we're going to have to travel at a 45-degree angle there, and we get that. But if we do have calculator, definitely go in the calculator here. So on the calculator, let's see what mode we're in here. I'm in degrees. So if we do inverse tangent of -1, we get that it's -45 degrees. So that's telling us we're traveling -45 degrees that way. That would be our angle there. And so our angle is -45 degrees, which if we convert into radians would be the same as -pi/4. So some ways we could list that out then. We could list it out as square root 2 comma -pi/4 would be one way. If you'd want to, you could find that coterminal angle. What's going to take us this way around to end up at that same spot. So to do that, you could do like what's 360 minus 45, which would be 315. And then if you convert that over, 315 degrees would be the same as 7pi/4. So then you could also list this as 7pi/4. So either one there, either one would work as an answer.